This is a Panasonic PT-L780U 3 LCD projector, which was first released roughly 15 years ago, back in 2003. I happened to find the press release for this projector, and as you can see here, there are some of the key touted specifications. Weighing only 12.8 pounds, which is very heavy for a projector nowadays, and the vivid images is only in true 1024 by 768 XGA resolution. And perhaps the most striking is if you look at the price tag here, the suggested cost is $6,199. So that was quite an expensive commercial projector. So where did I get this unit? Well, it was in a pile of to-be-thrown-out electronics at work. Nowadays, pretty much all conference room projectors have gone out of fashion and have been replaced with large screen LCDs. For instance, at my workplace, the conference rooms had been fitted with 80 plus inches LCD TVs, which offer much better image quality, especially in terms of brightness. And just to give you a sense of actually how big that unit is, here I have another projector for reference. And this one is a pretty standard size for conference room use. And as you can see here, this is roughly less than 1/4 of the size of the projector that we have here. But of course, do keep in mind that the PT-L780U was marketed as a commercial projector, and as such, it has some quite unique features here. So for instance, it can be mounted either right side up or upside down, depends on your specific situation, and the image orientation can be adjusted in firmware. It can also be used as a rear facing projector, and also the projector firmware does all the tricks for inverting the images depending on the placement of the projector. By the way, this unit still works perfectly and only had about 800 hours of lamp life, which is less than half of the rated 2000 hours life. But what we're going to do here is, of course, take it apart and see what's inside. And I only need to take off 6 screws, which are all clearly marked for holding the top cover down. So now I can hopefully open this up. And here we go. And by the way, this rear fan door actually opens up because the projector lamp is right inside, so you can just open this up and replace the lamp itself without having to open the whole unit. So with this open, let's take a closer look at what we've got here. I really like the construction of this unit because we can lift the top cover up and everything remains on the bottom board. So you can easily work with this unit without having to worry about wiring connecting various pieces of the circuits. So first thing first is you can see I can already recognize some of the components here. And the first thing I recognize is this AD9888. This is an analog LCD driver, which presumably is to driving these, I'm not sure if it's just one, I assume it has to be 3 because we only have one of this here. So it's to drive all the 3 LCDs used for this 3 LCD projector. And if you look towards the back here, we have a Altera Apex EP20 series of chip. This is the chip that is a CPLD, I believe, and it holds some of the glue logic for coordinating various parts of the circuitry. And of course, we have Pixelworks. So a lot of the projectors have these proprietary, I'm guessing, it's a central processor. And we have another chip underneath here. I don't know what that is yet, but it does require a heatsink. That's why it's under this portion of the aluminum heatsink here. So although this projector itself is bulk and heavy, the circuitry itself is actually quite highly integrated here. I was expecting to see a little bit more components on the boards, but it actually only has this single circuit board here, and which is not so different than some of the other projectors I did a teardown with before. And of course, the remaining space is all taken by the LCDs and lamps and some of the mechanical portions of this unit. And we do notice that we have quite a few fans here. We have one to the right, two to the right, in fact, this two here, and then we have two in the front. So the massive airflow is absolutely necessary in this kind of lamp-based projectors, because the projector can get really hot. In fact, if you recall, in one of my previous videos, I showed you that if you hold a piece of paper in front of the projector lamp, it will catch on fire. So that is why this massive airflow is absolutely necessary. And also, this projector does have two speakers, and I can see the driver chip is right towards here. It's a TDA chip. It is TDA 7056, I believe, and that's a audio driver chip. So that is driving these internal speakers. And I do see some empty slots on the board, and for example, there is a small place for either a EEPROM or something, I don't know. And also some of these connectors are empty, so I wonder why. This one looks like it's for a ribbon cable, either for an LCD or something, but interestingly, it's not connected, and I don't see any marking here suggesting what the purpose of this connector is. And also we have another connector here. No, this is not something that I removed the wire. There's no wire connected to this, so I don't know what that connector is doing there either. And because we have a clear view of the 3 LCD arrangement here, and also, as I mentioned earlier, the construction of this unit is such that all the components are connected here, and so we should be able to power it up. So I thought what I want to do is power it up and take a look at the LCDs here, and so we can understand the operation of this type of projector better. And now I have connected the power, so let's give it a go. I'm going to remove the cover here, and I'm going to turn on the power. It takes a second to warm up. And now the first thing you notice is that the 3 LCDs here, the red, green, and the blue, now lights up. So this is how the 3 LCD projector works. Basically, they have 3 separate LCDs. One is for blue, and one is green, one is red, and the lights through which combine together to form the final image. So basically have the 3 separate channels, one for each color. And now as it powers up, we can actually see, well, you can't see, but I'm going to show you here. So if I put my hand here, we have the image being projected. And this unit also has automatic zoom and focus adjustment. So let's take a look at how that works mechanically. We zoom out a little bit, and I'll show you here. So when I press on these are the focus buttons, you will see that this outer ring is actually rotating automatically. So there's a servo to controlling that. And typically the projectors don't have these kind of automatic approach, but since this is a commercial projector meant to be mounted on top of the on a rack and above the reach of a person, so you have to be able to adjust the focus and these type of adjustments automatically. So this is for focus, and these are for zoom. And the zoom is there's an internal motor. Sorry, there's internal some movements being adjusted, and you cannot see it from the outside, but you can hear that the motor is in action. And while I still have this unit up and running, I wanted to show you a little bit of this 3 LCD system in action here. So notice that the output is a combined output from the 3 LCDs. Right now it's outputting a blue screen, and if I turn the screen off, you'll see that the output is switched off. Now I switch it back on, off. So basically, the three components of lights are combined in the center optical component here and form the final image. Now I have removed all the mounting screws, all the speakers, and also the cables, and we can see this circuit board a little bit better. And obviously this is a multi-layer board, and the two big components here we couldn't see before, and right now they're here, but these are also this one is a Panasonic part, this is a TI part. I could not find the actual part number, but regardless, these are just for you know, processing images and stuff like that. Also, we have a PIC microcontroller back here. And so this is the board for the input control, and there's not much on the back of here, but it's a separate board. And so from the components, we can see that this unit was actually made at the end of 2003, I believe. Where did I see the date code here? And this is 0350, yep, end of 03. So all the components are end of 03. So this unit maybe it's was released in 04 or sometime after that. And so this is the main board. Actually, there's quite a bit more components on this than I originally thought. As you turn it around, you also can see there are quite a bit of components, RAM and logic ICs like that. So this is the main board here. And after we remove the main board, we can see that inside we have this power entry module here. Originally, I thought the power actually, the regulator is underneath this board, but if you take a look, actually I can just lift it up a little bit, and you will see that inside this is just some common choke for the power entry. So I believe the power actually is regulated on the boards beneath here. And this one would be a ballast and also the switching power supply board, which makes perfect sense. Now, originally I said it has 4 fans, 2 here, sorry, you can't see, 1 here, and 2 on this side. But actually there are quite a few more. So inside here you can see there's a squirrel cage fan here, and also we have another fan right here. So at least from what we can see, we have 6 fans in this unit. So I removed the top portion of the board, and we can see that the power entry board more clearly. Here we have the fuse, and we have 2 common chokes, so that's the board. And then we have this wire going through here, and that's the output from the mains connection here. It goes to the power supply board. And sure enough, as expected, this is the switching power supply module, and the wire goes from the other side directly to the power entry here. And as we also expected, that the top board is a ballast board. So it would be interesting to see if we can get this board working to power the lamp here. But of course, we are probably not going to do that in this video, and I will do a little bit of investigation, see if I can get that working. And as you recall, I did do one of that project back then. I will probably link the video somewhere, either towards the end of the video or put a link down below for those who are interested. And of course, if I take it apart further, I don't think I will be able to reassemble it and make it working again, but that's not the point. The point is, we're curious, we wanted to see how this thing works. And while I'm continuing dismantling this unit, I just want to point out some of the safety features here. So this is the power entry module. As you can see, we have an interlocking switch, which is not that uncommon. And this power, basically mains power wire, goes through, you can see here, a thermal switch here. So basically this thermal switch would disconnect the unit if it detects that the internal is overheated. So let me just zoom it in here. And that's the thermal switch right there. So this already has quite a few protection points here. Now I have taken everything out of the projector, and I'm pretty excited to finally get a chance to take a look at the optical components here. But first, let's take a look at how many fans there were inside this projector. Remember when I first opened it up, I thought there were 4, which was already quite a few. But later on, I found 2 more while I was taking the projector apart. Now with everything fully disassembled, let's do a final count. So let's start with the power supply module, and we have a fan at the end of the power supply. And then of course we have a fan at the power entry module. So those are the 2 fans we saw earlier. Oops, let me see here. So that's the fan. And we have a couple of blower fans on the various portions, and one I think is on the front, one is in the middle somewhere. And of course we also have another fan here, a fan here, and a fan here, and finally a case fan. This is I think is sitting right in the front besides the projector lens. So now you can see that we have 1, 2, 3, 4, 5, 6, 7, 8. Altogether we have 8 fans inside this projector unit, which is insane. So no wonder during operation the fan noise is quite excessive. Although this unit is designed for commercial use and typically is mounted overhead from the ceiling, so the noise actually doesn't matter that much. But of course, if you are using it in a home setting, and this will certainly not work at all, given the number of fans. And imagine if one fan is failing, you want to replace it, or you want to replace the fans with quieter ones. Imagine the amount of work that is ahead of you. And of course, given all these fans are different specs, and it's quite difficult to replace them. And of course, it's also difficult to find the quieter fans for the replacement as well. Now with the circuit boards and the fans out of the way, we can concentrate on the optical components here. So the first thing I want to take a look is this lens assembly here. And as mentioned earlier, this lens assembly is a motorized lens assembly. And as you can see here, we have 2 motors. One controls the outer ring here. This is the focus. And the other one is controlling the inner ring here. And this is your zoom. And so these 2 work in conjunction to control the zoom and focus. And of course, they're controlled by these control wires here. And in fact, these are just the standard motors. Each have 2 wires. And at first I thought that these must be a stepper motor because they will have 4 contacts here, but I guess it's not because they're just standard wires. Now think about it, it's actually stepper motor is not necessary because there really isn't any feedback. You are just simply using these motors to set a specific zoom level, and there's nothing automatic about that. So that's the lens assembly here. And now we can actually take this thing apart. This actually is quite neat. So let me just show you here. This is really just like a camera assembly, if I can get it to work here. You press it, you twist it, it comes off. And when you push it back, it clicks right in place. So it just feels like a camera lens. So it's quite nice here. But once you take that out, you can see this nice lens here. So I'm not sure what I can do with this, but that will probably for some later projects I will think about that. And once the lens is out of the way, you will see we have this the remaining module is really the 3 LCDs. And so these LCDs are marked. This one's for blue, this one's for green. Interestingly, we do have a red dot behind. I don't think the LCDs themselves are different. I think these are just the same LCDs, one for filtering each light. And then we have a combiner in the middle, and you can see that. So that's pretty much all we have here. And so once the light goes in here, basically the red, green, and the blue, they get combined and then comes out this way and goes through the lens and projects onto the screen. So let me put this back. And this, how do I do that? Okay, so this is right here. Yep, so now it clicks right in place. So it's a very nice assembly. I definitely will try to think of something cool to do with these, because otherwise it will be such a waste. Okay, so that's the lens assembly. Now let's move on to the other optical path of this unit. And here is our optical path assembly here. And so just to show you in relation to the lens where everything is you can see here we have the three color filters here. So basically the lens sits right in front of this here. So that's how everything is assembled. Once it's assembled, it looks like this, but right now I'm taking the lens away so that we can see the remaining parts here. And the discharge lamp is actually at the right bottom here, so I can slide this out, and you will see that this is your discharge lamp. And the two electrodes are here, and they're connected right like this. So basically, this is the unit you need to change once in a while. Now, this lamp only has about 700 to 800 hours of life. I forgot the exact numbers, but it's certainly less than the 2000 rated hours. And so it still has some life to it. And so inside, I actually already unscrewed the top, so we can take a look and look at the optical path here. So let me remove the top cover. And look at that, isn't that beautiful? So the light comes in here through these two Fresnel lenses, and you can see that. And then we go through this magnifying glass, I guess, and or this lens, and reflects through this side, and then splits into, I'm not sure exactly how the split is done, but each of these reflected surface, or the semi-reflective surface rather, it's going to filter out its corresponding wavelength. So the one going on the top would eventually be filtered out with the red only, and the one in the middle would be green, and the one goes to this side would be blue. So to see that, of course, I could just power up this bulb, but of course I don't have the power supply right now. I cannot hook it up yet. So what I'm going to do is I'm going to shine some bright white light through here, and we can see how this works. And here I have a white LED, and this one is pretty powerful. It's about 5 watts. So I'm going to place it in here, and I'm going to turn on the power here. So you will see that once I turn it on, and it's pretty bright, but the light comes out from here is red. You will see that. And the light comes out from here is green, and light come from this lens is blue, well, bluish. So this will be even more evident after I put on this filter, because the filter lens, you can see that this is tinted blue, this has a tint of green, and this has a tint of red. So if I put this on, you will see that the light comes out would pretty much be the color of their corresponding light path. So let's try it again. I'm going to cover this so it doesn't blind out. And on this side is red, and you can see that. And here is green, the middle, and you can see that. And the right, light come from the right, should be blue. And you can kind of see that. Not sure you can, but yep. Now you can see that's blue. So that's basically how the white light is split into the RGB components via this optical components here. And let me just open it up again, and we can see it in its in the detail again. So it's actually quite neat. I mean, of course, I'm no optics designer, but the optics here looks very, very interesting. As each of the lens, it doesn't have any color, and nevertheless, the color is split after it passes through this device. And that pretty much concludes the video. I hope you enjoyed the video and learned something new, and if you find the video interesting, please give it a big thumbs up, and remember to subscribe, share, and I will catch up to you next time.